Okay, so the last class we have discussed the ADVS. Okay, ADE is completed, and the next one is ADLB. Okay, this is the laboratory data. So the same thing, the laboratory and the vital signs would be the same thing. It's BDS data structures. Okay, basic data structure. So the main thing is here in the laboratory, you will have three classifications. Okay, three classifications. First one is hematology, which is related to the blood, then urine analysis. Okay, then the chemistry, the biochemistry. So in the laboratory, obviously, so we would receive the. It's not like related to the because we discussed right in the SDTM level. It's not coming from the CRF. So the results are directly coming from the lab or from the other source. So the the hematology, urine analysis, and biochemistry. So this data set will be have huge observations. So like sometimes you will be have 50,000 observations. So depends on the study. Okay, depends on the test, whatever the test they wants to conduct it. And recently in the new companies, so they have divided, instead of ADLBs, like the combining all these three classifications, instead of three classifications, they have divided like ADLB urine analysis, something, they have divided like that. So that the observation will be less. Okay, and so the basic data structure, it will be have the same thing, like one record per subject, one record per subject. Oh, so one or multiple records. Okay, one or multiple records subject. Okay, per parameter, and either per visit or per time point. Okay, so they have divided like this. Okay, and what else? So here also it applicable, the B type. So param type, there is no param type because the param type was included in the D type. So here also the same thing. You have to find out if you have aval value. Okay, aval, which is aval is the which is the your analysis value. Okay, your original result value in the numeric format. So this one, if you have any missing values, okay, you need to impute it. Okay, if you have any missing values, so you have to do as per SAP. Okay, statistical analysis plan. You have to do some missing, imputations. Either the last observation carry forward. So we have discussed these ones. So worst observation carry forward, or average, maybe minimum, maximum. So if you go more on related to the efficacy kind of, they will be have more. It depends on the SAP and depends on how they wants to do the client. Okay, the derivations. If you have missing values, because what happened, all the subjects, they don't go under the laboratory things. So for example, some subject, they don't want to do some kind of test, so they don't want to give their blood samples. So on the time, the aval value may be missing. So for that reason, they the SAP, as per, the statisticians, or they will recommend something to do the missing values. So most of the time you will have a D type, and also you will have the partial rates imputations. So it is same like the similar like how we did in the ADVS. Did we do any partial? No, we didn't do anything here. So is the partial rate imputation also, it will be given in in the SAP how they want to. So I gave an example for the ADAE. So it is a similar conditions. If you have any partial rates, how to do the imputations, those information also will be given there. Okay. So the ADLB, ADVS is almost the same thing, because they're also the vital signs, the same results they collected, and here also the different tests they have conducted. So it's almost the same parameters. Okay, so there is nothing much difference. So the basically as per the SAP, the source derivations most of the time is from the ADSL, So you copy all those information, and also from the vital signs. Sorry, this is vital signs. Why is this sense of signs? Okay, that's strange. Okay, so you have to get from the LB data set, not LB data set. Okay, so this all information you have to get from LB, not from the VS. Maybe the copy, but it's not copied properly. So LB test. It's the same like the vital signs structure. So here also. Okay, so wherever you have VS in this specification, you change to the LB. I think it's this
Ali,
yes.
Ali, quick question.
Yes.
Now there is AE datasets in SDTM level and there is AE datasets in ADAM level, right?
Yes, you have ADAE, right? ADAM level adverse
Yeah.
events.
So,
What's your question?
I mean, other than like here in ADAM level, basically, it's more we have to do imputation, right?
Yes, because what happened in the mokshes, in the tables and listings, you need to do some kind of extra variables. For example, they keep, the conditions, they keep like the tables you have to create for the treatment emergent flags. Those one you cannot do it because those variables not in the standard SDTM level. So those you have to do it from here in ADAE level. So, okay, and analysis data, like treatment emergent flag. If you
No,
have
but
like the partial dates, the partial dates, the analysis start date, because the treatment emergent flag, which is one of the major, the major thing from the adverse events. Here is you only have 4-5 variables, but in the real time you will have more. Okay, and the time they will be mentioned in the derivations also these things. It's all depends on your tables. Okay,
no,
tables and
because
marks.
I mean, why I'm confused is because now in ADAM level is this ADAE. There is nothing that we'll be using AE datasets that we made in SDTM level, right? Basically, we are using some other things, but we are not using any AE dataset that we made in SDTM level. Did you get?
You
I don't know
Yeah,
if I conveyed my
yeah,
question properly.
yeah, I understand because you are copying everything from here, right? So add all SDTM AE variables also because I missed this one.
Oh,
So
okay.
so adding those SDTM AE variable along with these variable you should be consider. Okay. Um, yeah, obviously if you need to do some kind of derivations here, you should need AE variables also, the SDTM variables.
Okay.
Um, so
Okay.
I
Okay.
guess I
Got it.
have, yeah, I have sent you the Roshi other one, right? In that you will be seeing more clear things. That is more complex things.
Oh, okay.
So
Yeah.
because you remember every time when you're doing the programming, we adding the AE and the VS, everything we adding in the initial way. The LB data set, then ADSL, then we're combining merging with this one. So including those variables, I think I forgot to add that one. I'm not sure. Let me check. So I have added, right, SGTM, AE variables, everything. Then I keep whatever the required variables at the end, those variables. But here I didn't do it. But in the real time, yes, you have to do all those as per the specification. You have to keep those variables. So here you also have to add all your SGTM variables.
Okay. Okay. Yeah.
Yeah, you don't skip the SGTM AE variables, and you should be there in the ADAM levels too.
Okay.
Okay. But most of the time, what happened in the specification and ADAM level, those variables you required for your to create the tables and listing, okay, the reports for the figures, those
Okay.
variable most of the time will be there only. So you should need your SGTM AE data set, obviously, because with these with those variables only you need to do the derivation here. the
Okay.
imputations, and
Yeah,
for
yeah.
example, AESTDTC, AENDTTC, those variable we cannot do directly from ADAM level, right? So those variable come from the SDTM level. So obviously you need those variables, and you keep it there. And if you go, if you go further in the tables, so the tables I'm showing you is just 5 tables only, which is I just give it you for explanation, because those 5 tables, most of the tables you can able to do it in the real time. But in real time there will be more than 200 tables, so it's going to be, is every condition they will be mentioned, like severity, adverse event severity, treatment emergent flags less than 30. So they put some kind of conditions in every table, serious adverse events, the mild 3 adverse event, what are the mild 3 adverse, so they classify like that. For adverse event itself they do like 20 tables.
Okay.
So it depends on the study how big is, so they go more than that one. So
Okay.
because I cannot explain all those things, right?
Yeah, yeah.
Because I just explain whatever I have resource that one. So anyway, so we're gonna continue with ADLB for today. So ADLB is the same structure, because I just took it the programming. I already did the programming, is almost the same, like similar like ADVS, because the same parameters. Okay, I'll show you the ADVS. Okay. So for initial one, you should need take your header part. So I took the LB, then Adam. Okay, so output should be ADLB. Then I copied all those. In real time, you will be have macros here. Okay, please remember those things, because if you run initializing macros, it does automatic everything. Okay, so you don't need to write in the links and to execute those things. Thereafter you have to copy all the variables from SDTM as well as from Adam. So how I did in the VS, okay, the same thing. So I copied the VS and the Adam ADSL, the same thing I did here also, the same thing. Okay, thereafter I merge these two along with ADSL and LB1, which is the SDTM LB. We can use the data step also, it's up to you, so whichever is feasible for you. Because if you use the data step, it should have to, the 2 steps you have to write, like either first you write data step, then you proc sort. So here it does automatic order by unique subject ID, it does automatic for 1 step. It's up to you. There is no like, oh, why did you use the proc scale, why did you use the data step? No one will say anything. As long as it works, it works. So I set the LB2. Okay, so here is I'm creating LB3 data set. So a visit, here is a visit. I remember I have mentioned for the visit windowing concept in the last class. It's almost the same thing, but because in the ADVS, how we took the visit, we took the same thing, because we don't have any kind of, as per SAP, we don't have any visit windowing concept. And it is very rare to get that concept, but if it is required, you already mentioned that I have sent the documents to you, right? For visit windowing, did I send it or not? Yeah, I have sent it, right? Did I mention, right? AW target, the last class I have mentioned this ones, the AWD, diff, low, high units. So this is one of the example in the visit windowing. If it is a target day, if it is week 4, if it is if your planned, I mean your actual date comes in this duration, that you have to consider as week 4 for the A visit. So I have mentioned as an example. So I have sent this one to you also. And this is a patch code, you can use it if you need to do any kind of visit windowing concept. Okay, so here we don't have a visit windowing concept, that's why I directly map to the visit. For the period, we're taking the periods, period 1 and period 2. Okay, and the numeric part is a visit now. I'm directly mapped to the visit now. Sorry, not this one. Yeah, visit now. Okay. And the param. So the param is a similar like ADVS, the combination concatenate of VS test and the VS test units, okay, standard units. So here also the same thing, LB test and LB standard units. Okay. Then, so if you have a missing values for the units, you just directly keep the LB test. Okay. So if he is mixed, if it is standard units equal to missing, then do param equal to strip of LB. This is one of the condition, okay, for if you have any missing values for here. So you just need to LB test will be pop up there, okay. And the param CD, the same thing, the LB test CD, which is short name. So here also the same thing, param CD, VS test CD, and here is LB test CD. And this very important issue, you would be getting a question in the interview, what is the param and how do you concatenate, like what are the variables you need from the SGTM to concatenate. So you would say like LP test, LP standard result units, and it all depends on on your mock shell also. Sometimes the mock shell, they don't need the units. Most of the time you will be have units, but they will also have some other parameters to concatenate. So if you say like most of the time LB test and LB standard result units, that should be good. So the param city would be LB test city, which is a short name. Okay. So here there is one extra variable here is category variable, like parameter category. So here we do LB cat, because in the VS we don't have any categories like hematology, urine analysis. We don't have that one. So here we have it. So the LB cat is based on, is classified like 3, right? Hematology, biochemistry, urine analysis. So if it is parcat 1 equal to biochemistry, then I give the numeric is 1. If it is hematology, I give 2. So if it is urine analysis, and this order also is based on the standard, okay, the format was given by the lead programmer or the statistician. So don't do any kind of the urine analysis first, and so you have to confirm with your lead programmer before you do these things, because if you give 1 2 3, and this is the same thing you will follow for the next one, okay. When you do the sorting in the table levels, if you do in different way, you will get messed up at the end. So try to get the formats initially, like what are the numbers you have to give, and this is very standardized, okay. Then you sort the data, the LB3 data. Okay, let me run this one here. Okay, you see 3,920 observations. So this is a simple thing, and we have that many observations. So LB3. Well, it's not that much complicated for do the LB data set. Even though if you have many observations, but as long as you make a programming correctly, it would be good. Um, Follow the step by step and check the specification and the programming notes, and do the same thing as per the the specification. It's gonna be work. So I got all you the param, the param cd, and the parcat. Okay, the parcat one I have given this one. Then I sort by param cd. So I keep the param cd, and if I have any duplicate values by variable, okay, by param cd, I'm removing those ones. Okay, so the basically what I did here. So I just keeping the only param cd, okay, and just keep the param cd in this data set param. So I'm removing any if you have any kind of duplicates, right? So because I'm trying to segregate the param cd, so that's the reason I have 28 parameters here. So you can see, so all those laboratory parameters, okay. So we have everything: hematology, urine analysis, biochemistry. These are the parameters. It will be working for each subject, okay. These are the tests they are doing in this project. So I have separated that one. Why did I separate it? Because I need to do the, you remember the in the VS we did here like this, right? The param 1 1 2, instead of writing like this, okay, because we have almost 28 parameters, instead of if it is ALT, then parameter 1, instead of doing like that, I just created like something. I took the observation, number of observation. This is like automatic variable. Okay, so this one, so this value. Okay, so I took that one, and if I run this one, let me go. Okay, the param will be the new variable will be added here. So it's a CC, so everything come like 28, almost the same thing, 28. So I gave the number like that. Instead of writing if ALT equal to then param and param CD equal to ALT, then param n equal 1. Instead of writing up to 28, I just use this use of automatic variable, observation variable. Okay, so then I sort by param CD for LB3. Then I have merge. Okay, so I have merged the param and LB3, both of them. So if we go LB4, so we got 3920 observations and 66 variables. Okay, so we got paraman because in each subject, for each ALT has 1, so that's showing like 1, and if you go further, you will be see 2, 3, 4 like that. Okay, so up to here, do you have any doubts?
No, Ali, clear.
Okay, so thereafter we sort the same thing like in the vital signs. So we sort here, we sort based on the category, then based on the parameter, and based on the visit void and the LB date, collection date. Okay, the laboratory result collection date. So in the vital signs, we have classified as a parameter, visit wise, then time point wise, then the vital signs collection date, right?
Ali, one question: is there any key variable list for the Adams also? We have for STM, na?
QA variables.
Key variable list to sort the data.
No, I don't think so. We don't have that one. No, it's only for in GTM level on. Yeah, we don't have that. Because it's a general concept, right? It's a general thing. So let me check. We don't have it. I never use it. No, I don't think so. No, it's only in the SDTM level only. Okay. This is Adam, right? Oh, sorry, this is the one.
Even for SDTM level, when you say key variables, basically you will just copy everything from the Excel sheet, what you get, right?
Well, in Excel sheet, in the specification, they don't mention any kind of,
key variables.
The key variables. So in the
yeah, they won't mention, but whatever is in
yes.
Excel sheet, we'll use all of them. We will not miss anything, right?
In Excel sheet, they don't mention anything the key variables. You have to go to the for SDTM level, or are you asking for ADAM level?
No, Ali. Now say I'm making SDTM data sets. Okay. Finally,
yes.
when I am sorting or whatever, when I use by variable, I'll basically take all the variables that are in Excel sheet and I'll paste it, right?
You said Excel sheet from specification.
Yeah,
specification. You take all these variables.
Sorry. Yeah.
You take all these variables.
Yeah.
Why are you taking all these variables to sort?
No, keep. I mean keep.
Oh, at the end. You mean at the end?
Yeah.
Yeah. At the end, you keep all those variables, whatever in the specification, you keep it. Yes.
Now
we were talking about the key variables, KEY. Balakrishna is asking for key variables. Is the same thing like in ADAM GTM levels, or do you have something in ADAM level? He's asking like that. Okay. So in ADAM level, what happened is based on the tables. Okay, if you go to the tables, you will find it if you go to the vital signs one. Okay, nice. Laboratory, we need laboratory. You see here, this is a category first, then parameter first. Thereafter, the remaining ones, the treatment is after. So we kind of taking this kind of, the measurement in case if you need to do the initial, which one is come first, here we took the paracat, which is the first one, then parameters, and then after that visit wise, obviously these are visit wise, and we don't have any time points. So after that LBDTC, so these are the collection data. So if you check in SDTM level also, you will have the same thing. Let me check. Okay, so if you see in SDTM, okay, I don't think I haven't sought here or what. You see LB test CD, then visit wise. Okay, this is the param CD. Here they mentioned the param CD and the visit wise, because in LB, so we took the param. Okay, paracat one is either you can take param or LB test CD. It doesn't matter, because is both are the same. This is a short name, this is a long name, so it doesn't matter whichever you take for the classification. Okay, and the visit word and LB collection data, and based on the mock shell only I took it. So here the category, then parameter, so to sorting purpose. So if you take in either way, it doesn't make any changes. Okay, you can use, because I usually take the paracat, paraman, and the numeric should be always first if you have a character here. Okay, so here also this, you see visit n and visit, so the numeric should always be first. Okay, that is, you just have to understand the paracat one, then after the character one. Okay, hope you understand. So the next one, we have other variables to create. That's the same thing like ADVS, the oval. Okay, so I took, because we are using first dot parameter, that's why I sorted here the same key variables, whatever I use it here. Then so I will explain this retain base and shift. Okay, so if you are deriving the base, so you're just keeping the base. Okay, let me show you. Okay, let me set this one first. Okay, let me take this one. So first I keep the first dot parameter, okay, which is the first variable. Okay, the parameter, the first, not variable, first observation in each parameter. Okay, whatever the because each parameter has multiple records, right? For ALT you can see almost like you have 32, something like that. So if you have first dot parameter, then base equal to missing. Okay, so once you write this statement and you keeping all those observations, the base should be missing, like just period there. So I retain the base. Okay, so why did I retain the base? Because we have to continue with other, if you have oval here. So let me show you the retain things. So this is the format statement. We give best 12 dots. So I'll explain this one after. So first I explain the oval. So oval is the analysis value. So obviously the similar like vital signs, we give the standardized numeric result. Okay, we always take standardized result numeric. Okay, so we directly as per the spec. Okay, so oval is a numeric version of LBORS, but here is LBORS, but actually is standardized. Okay, standardized STRES. So the next one, analysis, which is the convert the character format of value, analysis value, which we converted into the numeric. And the units is a laboratory units. Okay, it will be standards. Up to here, you okay, right? Then if you want to do the base, because the base, what is the base? The prior to administration, the value which is considered for prior to administration, that value we consider as the baseline. Because the base, because of the base only, you have to calculate the how much the shift has happened in the post baseline, like before the drug, after the drug, there are some calculation you have to do, and we need to do for that one. We need to create some baseline and the analysis baseline plan. Okay, so the first what I do, I retain the base. Okay, So I retain the base for the whole observations, okay, all the observations. Okay, shift one because we haven't done this, so I just this one like that for now. Initialize, where is shift one? Yeah. Okay, so I'm retaining the base for all the subject. Okay, so let me check the LB6. I'll show you. You see the base, I put the period for all observation. I'm retaining that this value for all observation for derivation. Okay, so once I keep that one, okay, let me take this one out. So then I come to here. Okay, so the 0. So 0 hours. Okay, if a visit n equal to 0 hours, the visit, like, which is a screening. Okay, because this is numeric format, that's why it doesn't show, you know, anything kind of apostrophes, you know, quotations. So then the base should be aval. Okay, then analysis baseline flag equal to y. So if it is base is aval, that value would be considered as a baseline flag, because whatever we give the base value for the analysis, and that value should be keep it as a y. I'll show you one second. So the shift one, I'll explain this one after. Okay, so up to here. Okay, let me do this one. What is this? LB6. Okay, you see the base. So if whatever the aval value you have, it comes here. And wherever you have some, you know, kind of missing, there you will have missing. You see here. So this is the reason I put retain this period for this reason, because there are missing values there. So that's the reason I keep it retain those ones. And also I did the same thing with the shift one. Shift one variable, basically in the LB data set, if you go to the LB data set, okay, laboratory range indicator. I have explained you. Oh, yeah, here. Okay, so I have explained you in the LB level. If it is there is a shift. Okay, there is a shift from the post before baseline, after baseline. That value is, you know, the given, like, is a normal or abnormal, is high, you know, before the post baseline. So when you go to the LB data, I'll show you. Don't be confused. Okay, so I have explained you the last time. So we have original results and original units, then upper value and lower value, and these are the standard results and standard in the numeric format. Okay, so for example, we have low and high, right? That is upper and lower range. Okay, and if it is your values in between this range, okay, then you would be considered as a normal. If it is above that range, you will be considered, you know, like high and normal. So this is the range indicator. So this should be have to pop up as per the specification. The shift baseline result, the base value refers to the last result prior to the administration of the first dose of study medication. Okay, based on these derivations, so laboratory, why this mentioned here? Because actually it comes baseline value, right? That is the base it has to become. Because the last time also we have kept base. Yeah, shift one equal to base. Okay, so why he put LB range indicator? Actually, this is a base. Okay, don't confuse with that one. And I put the shift retain for base for everything. For the base is AWAL value, so it's going to be the same thing for all the shift values. So if you, so I remove this one. So I'm applying some format for the shift one. Change percentages and initialize. Okay. So LB6. Okay, so we got our base and the shift one and AWAL C, which is a character format, and the unit and the baseline flag equal to yes. Okay, so this is the first the first dot parameter. So the first value that would be considered as a base, right? In the zero level, in the zero screening level. We don't have the periods here. So we don't have that information. So this is a screening, and this is a period 1, and this is a period 2. Okay, and this is a screening. So we put the base is equal to a visit n equal to 0, right? That's the reason that value we consider as a baseline flag equal to yes. Okay. Hopefully you understand, right? Hope you understand. Did you find any confusion, or you okay? Okay, so the next one, the same like vital signs. If it is base not equal to missing and AWAL not equal to missing, then and this is a calculation, the change equal to AWAL minus base, and we did the same thing here also, AWAL minus base, and the percentage change also AWAL minus base by base into 100%. Okay, and here we are deriving the treatment related information, so it's not mentioned in the specification. So here they mentioned the plant treatment, but in the LB we are taking in the consider as the one, like the 2 periods I'm consider as a plan 1 here, TRTP and the TRTP. Okay, so if it is period 1, A visit equal to period 1, and that would be considered as a treatment 01P. Okay, the TRTP would be treatment 01P, and if it is period 2, then the TRTP would be period 2. So I'm just mapping to the TRTP, the both, because in the ADSL level, we have a data structure like one subject per per record, right? So on that time we have divided the treatment 01P and treatment 01PN, and then 2P and 2PN. So here in the LB data set we don't need it because it's the multiple data sets, right? Multiple records. So so we don't need to be do it like so. I'm combining again, separating like plan, numeric and actual, the same thing. So I do the same 01 and the 02 also. So you can see, 1 second, I'll show you.